The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to Eagle Point Funding's webinar, Department of Defense Small Business Grant for Materials, due October 24th, 2018. I'll be today's presenter. Alfred Hamel. I'm the Director of Marketing and Sales Support here at Eagle Point Funding. Here's my contact information, my email, my phone number if you need to reach out to me anytime. So we'll begin today's topic by giving you kind of a quick breakdown of SBIR STTR. I'll give you an overview of how SBIR STTR works. I'll talk to you a little bit about federal funding, and then we'll jump into the topics. There are 30 topics today for the materials, so it might be a little bit of a longer webinar, but I'll try to make it quick because of the length of the material and the length of the topics. So SBIR stands for Small Business Innovation Research, and STTR, its sister program, stands for Small Business Technology Transfer. These two programs support R&D and financing of cutting-edge technologies. They're the staple federal funding programs to receive federal funding from the U.S. government. These are some stats quickly about how much money is given out annually and to date by the SBIR STTR programs and how many awards, and it's from the SBIR website. You can visit it at www.sbir.gov. Just to give you a little background, the SBIR program I just mentioned, it's a simple, straight company applying for a grant on its own program. There's the sister program, the Small Business Technology Transfer STTR program, and that program involves partnering with a research institution or university. This program takes up about a little over $250 million of the extramural budget. Whereas the STTR is a little bit larger. But just so you know, there is an STTR program for the DoD award coming up. We're focusing today on SBIR. These are the four goals of the program, of the SBIR STTR program. In short, meet federal research and development needs, increase private sector commercialization of innovation derived from federal research and development funding, stimulate technological innovation, and foster and encourage socially and economically disadvantaged persons. Basically, these are the four goals of the SBIR STTR program. The government is looking to invest in entrepreneurial small business endeavors that have cutting-edge technology. There are three phases to the program. I'll focus on SBIR for the purposes of this slide. The first phase is $150,000 for 6 months. The second is $1 million for 2 years, and finally, phase 3 is commercialization without SBIR funding specifically, with about $1 million as well. I'll give you some background on the DoD's regular SBIR STTR awards. There are 3 announcements throughout the year. This announcement is for October, upcoming October 24th. The DoD makes up about $1 billion of the annual SBIR budget. It's the largest player in the space, so it's a big deadline approaching. Here are some stats about who wins. Fewer than 25 people type firms are over half of the awards. A third of the awards are to firms with fewer than 10 people, and a fifth are minority or women-owned businesses. Here's a list of the agencies that participate in SBIR. There are 11 participating agencies. Please note that I'm about to show you in the next slide, STTR has fewer participating agencies. All of them participate in SBIR. As you see here, only 5 participate in STTR. Don't be surprised by that. Now you know that. There's a difference between the participating agencies. That wraps up the intro to SBIR STTR. I'll talk to you quickly about federal funding. Here's a copy of the budget for this year, $176.8 billion for 2018. It's up from $151 billion from last year. There's expected to be closer to $151 billion, and it's up to $176.8 billion. There's a lot of money available for federal funding. R&D grant mechanisms. SBIR STTR make up only 3.6% of the pie. 96.4% is BAAs, or broad agency announcements, which are larger grant opportunities. We work with BAAs too. If you wanted to consider a BAA, we could help you with that. For the purposes of today, we're sticking with SBIR, but just keep in mind there is a lot going on with the BAA as well. The differences between dilutive and non-dilutive funding. Non-dilutive funding means you don't give up any equity when you receive a grant. Unlike dilutive funding or venture capital, you have to give up equity. Non-dilutive or federal grants, you give up no equity. There's no interference, no board members, no advisors. You retain all IP rights. You don't have to give up anything. Okay, so now we've reached the topics. As I mentioned, there are 30 topics. I'll try to run through it as quickly as possible, but this should make up the meat of the webinar for today. Topic number 1, power conditioning surge module for standalone power and tactical microgrids. This is through the Army. The idea is to design and develop a power conditioning surge module capable of enabling of military power systems to better handle nonlinear loads and power surges in excess of 125% rated power for 3 to 5 seconds. Topic number 2, high temperature polymers for 3D printed injection molding tooling. Through the Army, the idea is to develop and demonstrate a high temperature polymer suitable for use as tooling for high pressure injection molding operations. The polymer should be capable of being 3D printed via fused filament fabrication processes utilizing a commercial off-the-shelf or minimally modified commercial off-the-shelf 3D printer. Topic 3, reducing agglomeration of explosively disseminated aerosol powders. Through the Army again, the objective of this effort is to develop a model capable of describing the explosive dissemination of a compacted powder. It should be appropriate for small-scale devices, for instance a hand grenade. Understanding the underlying physical and chemical principles controlling explosive dissemination of powders is a primary knowledge gap. Of equal importance is determining how the powder's material properties and packaging affect dissemination. Discovering the mechanisms responsible for agglomeration. The agglomeration of powders is necessary to tailor the dissemination process for effective screening of the electromagnetic spectrum for future obscuration missions. Topic 4, rapid expandable mobile shelter for mission command. This is through the Army again. The objective of this effort is to develop a rapidly deployable shelter that provides greater expeditionary capabilities at the squad level in combat operations in multi-domain environments and mission command. The development of this system will result in improved mobility, reduced battlefield signatures of personnel, equipment, and communication facilities, enhanced speed and agility for dispersed combat operations in multi-domain operational environments, including mission command. The protection capabilities that could be provided by this system would enhance soldier protection on the battlefield, thus increasing soldier lethality. Topic 5, individual soldier small unit desalination device. Through the Army, the objective of this research is to develop a soldier portable device that can remove salts from seawater and brackish water sources to produce drinking water at a rate of 1 liter an hour per soldier, up to a maximum of 9 people. Additionally, this device will require no or minimal external power requirements. Topic 6, armor support ring optimization. Army, optimize a part and develop an optimization process program. This project will investigate materials and manufacturing methods to reduce the cost and maintain the relevant performance requirements for an existing part. The armored multi-purpose vehicle armor support ring will serve as a proof of concept. The armor support ring for the AMPV, or armored multi-purpose vehicle, is currently machined from titanium, which is ineffective. Topic 7, an open call for innovative defense-related dual-purpose technology solutions with a clear Air Force stakeholder need. This is through the Air Force. The objective of this topic is to explore innovative defense-related dual-purpose technologies that may not be covered by any other specific SBIR topic, and thus to explore options for solutions that may fall outside the Air Force's current fields of focus that may be useful to the U.S. Air Force. This topic will reach companies that can complete a feasibility study and prototype validated concepts in accelerated phase 1 and 2 schedules. This topic is specifically aimed at later stage development rather than earlier stage basic science and research. Again, it's an open call. Topic 8. This is through the Air Force again. Integration of onboard distributed flow sensing using AF intellectual property. This topic will provide surfaces in flow-sensitive environments with large boundary layers, a low-power, low-footprint, distributed local flow speed via an APLIC, or integrated network, leveraging the artificial hair sensor technology. The artificial hair sensor technology was developed by the Air Force Research Laboratory. This technology is targeted to provide air vehicles with improved performance in gust alleviation, navigation in GPS-denied environment, and mapping of complex flows. Additional applicability exists for other high-performance flow measurements in the field where weight and power are highly constrained, such as a spoiler of Formula One car. Topic 9. Capping material for compacted runway crater repairs. Through the Air Force, develop a non-toxic technology that supports aircraft operations within an hour of application over a small or compacted runway repair, completely suppresses escape of debris from the repair, and survives 2,000 landing and takeoff cycles over 30 days. Topic 10. Lightweight replacement for AM2 runway matting. Through the Air Force, develop a robust sheet or roll technology weighing 3.5 pounds per square foot or less that can be laid by hand over level surface compacted to CBR 50 to contain debris and support flight operations for 5,000 landing and takeoff cycles over 60 days. Topic 11. An alternate corrosion-resistant coating to be applied to aluminum and magnesium secondary power system parts. Through the Air Force, identify and qualify corrosion-resistant coating applicable to aluminum and magnesium gearboxes, covers, and other secondary power system parts. New corrosion-resistant coating shall surpass the current conversion coating, which is slightly better protection than having no coating at all. Topic 12. An alternate corrosion-resistant coating to be applied to aluminum secondary power system parts. This is through the Air Force. Identify and qualify pretty much the same thing. A corrosion-resistant coating applicable to aluminum gearboxes, covers, and other secondary power system parts. New corrosion-resistant coating shall surpass the current conversion coating, which is slightly better protection than having no coating at all. Topic 13, again, quite similar. An alternate corrosion-resistant coating to be applied to magnesium secondary power system parts. Here it's the same thing, just magnesium. Topic 14, X-ray tomography through the Air Force. A CT scan, also known as computed tomography scan, makes use of computer process combinations of many X-ray measurements taken from different angles to produce cross-sectional tomographic images, virtual slices of specific areas of a scanned object, allowing the user to see inside the object without cutting. Improved aspects of X-ray tomography, XRT, as an extremely accurate, non-destructive solution to obsolete and unobtainable printed wiring boards, and facilitate generation of technical data packages for the U.S. Air Force. Topic 15. Microbiological contamination detection sensor for fuel storage tanks. Through the Air Force, develop and demonstrate an inline and in-tank permanently or temporarily resides within the confines of a fuel storage tank sensor to provide fuel tank managers early detection of the presence of microbial contamination in aviation or ground fuel storage tanks to allow corrective actions to be executed. 16. Identifying and remedying multiple trace contaminants in manufacturing environment to prevent bond failure. Through the Air Force, the objective is to define a methodology to quantify the combined effects of multiple contaminants, i.e. skin, oil, dust, etc., composite bagging materials, corrosion prevention, sealants, and environmental effects on the adhesive strength of composite material systems. 17. Okay, we're halfway through here. We're up to 17 of 30. 17. Power electronics thermal interfaces. Through the Air Force, the objective is to provide new interface materials and processes for device die attachment and electronics packaging with increased temperature range, mechanical strength, and thermal conductivity. There's a typo here. Topic number 18. Non-destructive inspection evaluation, probe, and aircraft structure coordinate mapping. Through the Air Force. Directly map non-destructive inspection evaluation point and C scan data with corresponding aircraft structure coordinates to allow engineering analysis and inspection data archival storage. This includes linking of the NDI inspection data to 3D volumetric data that are both acquired at the time and location of inspection, i.e. to the structure in the as-inspected configuration. This technology advancement will improve inspection results reporting, as this information will be directly linked and enable swifter maintenance and engineering actions. Topic 19. Automated precision coating removal. Through the Air Force, develop an automated or semi-automated coating removal capability to improve the quality and increase the speed of racetrack coating removal on advanced fighter and bomber aircraft. Topic 20. Structured light for coating application and removal. Through the Air Force, develop systems approach to accurately measure large area structures as well as small complex shapes, determine if item in spec, calculate optimized sanding, spraying operations to bring it into spec, and cue a robot to perform corrective operations. Topic 21. Experimental methods for predicting material interactions with plasmas. Through the Air Force, develop new experimental methods to evaluate material plasma interactions to advance material response models. At hypersonic velocities above Mach about 7, the flow fields near vehicle bodies become dissociated and ionized, forming significant levels of plasma. The objective of this effort is to develop and validate new techniques to test ultra-high temperature materials in high temperature, meaning greater than 1600 degrees Celsius, exposures, both with and without dissociated ions of oxygen and nitrogen. Topic 22. Affordable materials and coatings for pressure gain combustion. Through the Air Force, this is the last topic through the Air Force. Identify, test, and life materials, coatings, and components thereof in an environment representative of pressure gain combustion. The emphasis will be on ground testing of affordable materials for single-use air-breathing applications. Topic 23. Reverse engineering technical data packages for development of alternate sources of supply for the DLA Nuclear Enterprise Support Officer, NESO. This is through the DLA Defense Logistics Agency. Nuclear Weapons Information Management is a topic to improve product availability and increase competition through the development of source approval requests, or SAR, by small business manufacturers for national stock numbers, or NSNs. The government-provided technical data is the objective of this topic. Topic 24. Research and testing of unmanned aircraft systems, UAS, for the delivery of food and supplies in support of contingency operations. Through the DLA, Defense Logistics Agency, the topic here is drones, to develop and promote innovative UAS delivery solutions in support of contingency operations and natural disaster relief efforts in the subsistence supply chain. The DoD is looking for UAS drone technology that reacts quickly in support of mobilization operations such as disaster relief efforts, looking to test the delivery of food and water to a specified location, simulating an area affected by natural disasters in the United States. Topic 25. Enhancing the separation technology to recover rare earths, or REs, from chemical concentrates or industrial waste feedstock. This is through the DLA, the Defense Logistics Agency as well. The DLA R&D is looking for a domestic capability that demonstrates a new novel RE extraction and separation process from chemical concentrates or industrial waste feedstock. Various REs are used in defense weapon systems, and there is no domestic production of these materials and therefore a risk of foreign reliance. Developing an economically viable, environmentally friendly process for enhancing the recovery of REs from the existing industrial waste feedstocks, such as fluorescent lamps, electronic devices, could facilitate the establishment of a viable, competitive domestic supply chain. 26. Enhancing the superalloy recycling technology to recover strategic and critical materials from industrial and defense waste feedstock. This is quite similar. The DLA, again, Defense Logistics Agency. The DLA is looking for a domestic capability that demonstrates a new novel superalloy recycling technology from defense or industrial waste feedstock. 27. Enhancing the technology to process aerospace-grade chromium metal with low non-metallic impurities. Again, through the DLE Defense Logistics Agency, the DLA is looking for a domestic capability that demonstrates a new novel process for aerospace grade chrome metal production with non-metallic impurities such as oxygen, nitrogen, hydrogen, sulfur, and carbon. The chrome metal is used in defense, weapon systems, and there is limited domestic production of these materials and therefore a risk of foreign reliance. Almost done here. 28. Automated coating removal from germanium-based substrates. From the DLA, again, Defense Logistics Agency. The DLA is seeking to identify a domestic capability that demonstrates the ability to develop an automated coating removal system from germanium substrates. The automated coating removal system is critical to preserve the germanium substrates from traditional methods of coating removals, such as chemical etching or excessive grinding. Many of these coatings contain thorium, a radioactive and hazardous material, and the proper removal ensures that the germanium substrate could be reused or recycled into new products. Topic 29, enhancing the technology to process electrolytic manganese metal, EMM, from low-grade manganese ores. From the DLA is looking for a domestic capability that demonstrates a new novel EMM recovery process from low-grade manganese ore. The electrolytic manganese metal are used in defense weapon systems, and there is limited domestic production of these materials and therefore risk of foreign alliance. Okay, lastly, topic 30, partner force identification, friend or foe. U.S. SOCOM is the department from which this topic is coming, or U.S. Special Operations Command. The topic here is communications. To develop an innovative, low-cost, expendable way to identify partner forces operating in combined formation with special operation or other U.S. forces, whether friend or foe, is the goal here. Language used by the DoD about this topic is to, quote, assess what is in the art of the possible. That might mean a system or an infrared signature in invisible band. So there's a lot of leeway for topic research here. Okay, that wraps up the 30 topics. I ran through it as quickly as I could muster to try not to bog anyone down there. I think we did a pretty good job in terms of time. We'll wrap up the webinar now pretty quickly. I'll give you a little background before we end about Eagle Point Funding and who we are. We're an international consulting firm specializing in non-dilutive funding. We're the biggest of its kind in the world. We were established in 1999. We have 70 plus full-time employees. We have 250 plus active clients. About our successes, we use a multi-submission strategy. We have over $1.5 billion awarded to date and roughly $70 million annually, and we're a success-oriented business model. For this award, it'll cost $5,000 to do SBIR Phase 1 with a success fee of 5%, and the same thing for Phase 2, $5,000 and a success fee of 5% for this DoD SBIR opportunity. I'll take this opportunity just quickly to say, if you saw a topic today in materials that you think you have breakthrough technology for, that you should definitely apply in our opinion, and we think your best chance of winning is with us, and that you should feel free to reach out to us, and we'd be happy to work with you to apply. Okay, at this point I'll do a little Q&A. Feel free to ask any questions if you have any. In the interim, and you can do that by submitting a question in your webinar box. In the meantime, I'll do a couple questions of my own. I think a great topic for questions to start with, a lot of people think about, is what does it take to get from Phase 1 to Phase 2? What's the difference? So I'll just say quickly that I know that Phase 1 is more about feasibility, whereas Phase 2 is about a prototype. So Phase 1, you don't need a prototype. What you need is the commitment to do research. By the end of Phase 1, you're expected to have developed a prototype. It is with that end of Phase 1 that you're expected to go into Phase 2, having now created a prototype, and that's the expectation in Phase 2. Phase 3 is about commercialization. Those are the differences between the three phases. So keep in mind, there's a huge difference in terms of need for prototype between Phase 1 and Phase 2. You need a prototype for Phase 2, but not for Phase 1. Okay, and then quickly, a very popular question that's pretty standard that I'll just review. how much money is available for awards from federal grants. For SBIR, Phase 1, Phase 2, and Phase 3 total, it comes out to about $2,150,000 total if you win successive Phase 1, Phase 2, and Phase 3. Again, to review, Phase 1 is $150K for SBIR, Phase 2 is $1 million, and Phase 3 is $1 million. Then, that being said, there are BAA's broad agency announcements, which I mentioned at a certain point in the webinar, that offer larger grants that could be $1 million without going through SBIR that you might be interested in, that definitely have opportunities in the materials space if that's where you're working, because you're at this webinar about materials. Okay, I don't have any questions from the audience, so I'll move on from the questions at this point. Here's a quick list. We're about to end the webinar, but quickly, of the upcoming webinars in this DoD series. Tomorrow we'll be covering infosystems, Thursday nuclear processes, next week Monday air platform, Tuesday battle space, and then next Wednesday STTR for the DoD upcoming deadline. Keep in mind the deadline is approaching October 24th, so if you're interested in applying, you should be getting together your application, and if you'd like our help, we're available for calls until then to try to set something up to try to work with you to help you win a grant. Okay, and that should wrap it up. I really appreciate everyone joining and sticking around. It was a longer webinar because of the longer list of topics. Let's make a time to chat. Here's a link to my calendar, and here's my contact information again. Feel free to reach out anytime. Here's my phone number and my email address. It was a pleasure hosting this webinar, and I really appreciate it. I hope everyone has a great rest of the day, and best of luck. Take care. Have a good one.